On July 16th, 2026, a group of developers ran a blind test. Code from different AI models, stripped of any labels, judged purely on quality. In the mix were two of the most expensive, most talked about systems on the planet. One from Anthropic, one from OpenAI. The model that came out on top wasn't either of them. It was a name most people outside China had never heard: Kimi K3. Kimi K3 is the newest flagship model from Moonshot AI, a Beijing based lab. And on paper alone, it's a strange thing to have come from a company most of the world barely knows. It's a 2.8 trillion parameter model, making it the first open weight model in what researchers call the 3 trillion parameter class. That's not a small distinction. Frontier scale models of this size have, until now, almost exclusively lived behind closed doors, locked inside proprietary APIs from a handful of American labs. Kimi K3 breaks that pattern. It's open weight. Anyone can download it, inspect it, modify it, and run it on their own hardware. So, how do you make a model this large actually usable? Moonshot's answer rests on two architectural ideas. The first is something they call Kimi Delta Attention, or KDA, a hybrid linear attention mechanism. Instead of applying the standard computationally expensive form of attention across every single layer, KDA reserves that heavier processing for the layers where it matters most and uses a cheaper linear approach everywhere else. The result? A model that can handle a full 1 million token context window without the cost exploding. The second idea is called attention residuals. Rather than accumulating information uniformly as it moves deeper through the network, the model selectively retrieves the representations it actually needs from earlier layers. Think of it less like a snowball picking up everything in its path, and more like a librarian pulling exactly the right book off exactly the right shelf. Layer on top of that a heavily sparse mixture of experts setup. Out of 896 available experts, only 16 activate for any given token. And you get a model that's enormous in total size, but far leaner. In the compute, it actually burns per response. Moonshot claims this adds up to roughly 2.5 times the scaling efficiency of their previous flagship K2. Numbers aside, the real question is simple: is it actually good? By most independent measures, yes, remarkably so. On the Artificial Analysis Intelligence Index, Kimi K3 lands in third place overall, trailing only Anthropic's and OpenAI's top tier models. On the Val's AI Index, it ranks second overall. And in that front end code arena blind test we opened with, it took first place outright. It's not without trade offs. Kimi K3 is notably slow, generating around 32 tokens per second, well behind the median for models in its class. It's also verbose, often producing far more reasoning tokens than comparable models to reach the same answer. And it currently runs about $3 per million input tokens and $15 per million output tokens, pricier than the typical open model, even if it's still a fraction of the cost of the closed frontier systems it's competing with. There's also a quirk worth knowing if you plan to build with it. In ambiguous situations, K3 tends to just act rather than pause and ask for clarification. Researchers have pointed to this as a common trait in heavily specialized mixture of experts models. The individual experts get very good at taking action, sometimes at the expense of checking in first. Now, let's push Kimi K3 even further. Instead of generating just backend logic or writing a few functions, I'm giving it a single prompt to build an entire game application from scratch. Watch what happens. With just one prompt, Kimi K3 starts putting everything together: the complete front end interface, the backend logic, game rendering, user input handling, scoring system, animations, and the core gameplay mechanics, all in a single generation. There's no need to manually stitch together different components or switch between multiple tools. The model understands the full context and assembles a working game structure from beginning to end. This isn't just about writing correct code anymore. It's about understanding how an entire application should be designed, connected, and brought to life. Within moments, you can already see a playable prototype taking shape. The UI is generated, the game logic is wired up, user interactions are handled, and the project structure is organized automatically. For developers, indie game creators, and anyone experimenting with AI powered development, this dramatically reduces the time needed to go from an idea to a functional prototype. Instead of spending hours setting up boilerplate code, configuring rendering engines, or connecting front end and back end components, Kimi K3 handles much of that heavy lifting for you. Of course, you'll still want to review, refine, and customize the generated code, but as a starting point, it's remarkably fast and surprisingly complete. This is a great demonstration of how modern AI models are evolving from simple code assistants into full stack application generators capable of producing interactive software with a single prompt. Here's why this matters beyond a leaderboard. For the past couple of years, there's been a comfortable assumption in the West. Open source models, and Chinese models especially, trail the closed frontier by about a year. And when they compete on price, not on raw capability. Kimi K3 challenges both of those assumptions on day one. This isn't the first time a Chinese lab has done this. DeepSeek's R1 release rattled the industry by showing a lab could move fast into reasoning models and ship ahead of larger, better funded American competitors. Kimi K3 is a different kind of story. Not a sudden pivot, but a demonstration of a lab methodically executing on every lever available to it. Data, algorithm design, architecture, and tooling all scaled up together. And the demand has been real. Within 2 days of launch, Moonshot had to suspend new subscriptions. Their computing capacity simply couldn't keep up with how many people wanted in. Naturally, this kind of leap invites scrutiny. US officials and Anthropic have raised concerns that Moonshot may have trained K3 using outputs distilled from American models. Moonshot has denied this. Independent researchers who've dug into the technical details of K3's architecture have noted that the innovations described, the KDA mechanism, the attention residuals, the specific mixture of experts configuration, look like genuine engineering choices, not just a copy of someone else's homework. If distillation from closed US models played any role at all, most signs suggest it was a minor contributor, not the whole story. Whatever the truth turns out to be, the strategic questions are already back on the table. How effective are export controls really proving to be, and how big is the gap between open and closed AI when a comparatively small lab in Beijing can put out something that beats the best proprietary systems money can buy in a blind test? Benchmark numbers hold up once outside developers get their hands on the actual weights and whether people can adapt the model for their own specialized use cases. Moonshot has also confirmed that K3 launches using its maximum thinking effort setting by default, with lighter and heavier reasoning modes expected in future updates, giving developers more control over the classic trade off between speed, cost, and depth of reasoning. Whether Kimi K3 marks a permanent shift in the balance of power in AI, or just one very loud moment in an ongoing back and forth, one thing is already clear. The assumption that frontier intelligence requires a closed system and a 9-figure budget just got a lot harder to defend. The gap didn't close because someone found a shortcut. It closed because someone did the unglamorous work of scaling everything at once and gave the results away for free. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and tap the bell icon for more amazing facts. See you in the next video.